Hello, my name is Sharfalie Ramjohn. My group, consisting of Aaron Juan, Cara Queensberry, and myself, decided to do our case study for this class on Ticketmaster. This is my presentation. In this presentation, we're going to go over the overview, problem statement, user and audience, roles and responsibilities of each member in the group, the scopes and constraints of this project, the process, and the outcomes and lessons we learned along the way. Okay, so firstly, the overview. Ticketmaster is the industry-leading platform for ticket purchases, resales, connecting fans, venues, and sellers to events across the globe. Based on research from the previous class, we realized that most users were dissatisfied in 4 areas: the lack of price transparency, the complicated checkout process, ticket resale challenges, and lengthy wait times. As the go-to destination for some of the most popular and high-demand events, Ticketmaster often experiences a surge in user traffic, particularly from buyers eager to secure tickets. At the heart of this process lies the virtual queue, a critical component of the Ticketmaster experience designed to manage and promote fairness during ticket sales. Despite its intentions, the virtual queue usually does the opposite of what it intended to do. It has become a significant source of frustration for users. Long and often inaccurate wait times, technical glitches, and inconsistent functionality often leave many ticket buyers uncertain about their place in line. Buyers are sometimes disconnected mid-process or encounter errors that prevent them from completing their purchases, resulting in missed opportunities and dissatisfaction. This case study examines the challenges and opportunities associated with Ticketmaster's virtual queue. By analyzing the experience of frustrated ticket buyers, we uncovered key pain points such as lack of real-time updates. These issues have eroded user trust and satisfaction, hindering Ticketmaster's ability to deliver a smooth and reliable ticket purchasing experience. Through a detailed analysis of user behavior and expectations, this study presents actionable recommendations to improve the virtual queue's design and functionality. The ultimate goal is to create a transparent, efficient, and user-friendly queuing system that not only ensures fairness but also rebuilds confidence in Ticketmaster's platform. As stated previously, we have observed that customers struggle with lengthy and boring wait times for popular events, which has caused frustration, dissatisfaction, and decreased engagement. Our ticket platform is intended to achieve easy, transparent, and efficient ticket purchasing for all customers. Our goal was to aim at providing a more engaging, interactive, and accurate queue screen to our users so that they are more successful in the ticket buying process. You join the queue, you wait in the queue, and then you purchase your tickets when your turn comes. We believe that this would lead to reduced customer frustration and drop-off rates, leading to a greater volume of successful ticket sales. Throughout the testing and research phase, 45% of our participants were experienced with the platform, 35% had used it before but not frequently, and 15% were first-time users. For our target audience, this redesign is geared towards users who are actively attempting to purchase tickets but become frustrated and annoyed during the virtual queue process due to the lack of accuracy and interactivity or engagement, which ultimately led to drop-off rates. They value efficiency, transparency, and a smooth experience to minimize frustration and secure their desired tickets. These users want a seamless virtual queue experience that updates them in real time so they can understand their position in line and know how long they need to wait. They also want a faster and more reliable queue transition so they can secure their tickets promptly when it's their turn. Roles and responsibilities. So for most of it was a lot of collaborative research, brainstorming, a lot of collaborative work. But in terms of the areas that we excelled, Erin did a lot of the organization and visual research. Kara did a lot of the prototyping, especially with the flow and the connections. And I did most of the wireframing as well as assisting Kara in the prototyping. Okay, in terms of scopes and constraints, the first one, we understood that the redesigning of the queue is more of an infrastructure design first. In theory, Ticketmaster would have to change their queue infrastructure and software to be able to handle and accommodate not only the redesign, but the amount of traffic that they would incur, I guess. The amount of traffic that comes with their site, they would need to redesign in order to accommodate that. Secondly, due to the limitations of action triggers in Figma, we faced challenges in making our prototype as functional as we envisioned. For example, implementing a swipe down gesture to access the lock screen view proved difficult. Users often accidentally tapped the exit button at the top of the page instead of successfully swiping down, as we had to use a touch-up trigger for this interaction. With the development team, or more advanced and flexible triggers, we could have executed this feature more effectively. Lastly, we relied heavily on GIFs for animations, which limited our ability to achieve the desired effect. For example, instead of showing a seamless animation of a car driving by, which you'll see soon in the wireframe section, the prototype made it appear as though the car hit a wall. While this could partially reflect a skill limitation as well, the constraints of the tools played a significant role in preventing us from delivering the polished interactions we aimed for. Now it's time for our process, the way we thought, how we went about doing the design, the research, all of that. So firstly, we started by delving into the experience of Ticketmaster users through user research, focusing on ticket buyers in the virtual queue. Through this process, we identified key pain points such as inconsistent virtual functionalities across platforms, inaccurate wait times, frequent disconnections, and technical difficulties. By empathizing with users, we aimed to understand their frustrations and uncover actionable insights. To better target our efforts, we used the Jobs to Be Done framework, which allowed us to define specific goals and challenges from the user's perspective, ensuring that our problem solving centered on their needs and desired outcomes. We then moved on to analyzing this data using an opportunity solution tree to brainstorm solutions. Breaking down the efficiencies of the virtual queue, we identified manageable components such as the need for real-time updates and accurate wait times. Using this tree, we mapped out actionable solutions to address these pain points. This ensured our discussions and sketches moving forward focused on creating a more transparent queue system with engaging design elements, real-time updates, and improved usability across devices. Okay, so what we have here is a snapshot or a mini version of our opportunity solution tree. When buyers enter the queue, they want a seamless and engaging experience while waiting for their turn to purchase tickets. The opportunity would be efficient and transparent queue management, and the solution would be to show real-time updates on queue positions and estimated wait times to reduce uncertainty and reassure users. For example, 12th in line, estimated wait time is 45 minutes. Okay, so once we were done with the research and analyzing that research and all of that, we began brainstorming and trying to generate little design ideas. So to kick off this design process, we began with a crazy gaze exercise, generating multiple quick sketches of a potential screen. While doing this, we tried to highlight what was most important to users based on our research findings, knowing their place in line, their estimated wait time, and a visual representation of both. After generating these sketches, we voted on the best ideas, which we then combined into a unified, low-fidelity wireframe. After voting on the most potential aspects of the Crazy Eights and creating a low-fidelity wireframe, through iterative rounds, we refined this into a mid-fidelity wireframe, which you see on the far left, and eventually, a polished high-fidelity mockup, which you can see in the middle, making sure to incorporate user feedback to ensure the design effectively addressed user needs and aligned with the goals of improving the engagement and overall effectiveness of the virtual queue. For usability testing, we tested a total of 6 participants, 3 in class and 3 outside of class, varying in age, gender, technical experience, and of course, Ticketmaster experience. We observed 3 different sections and we asked 4 questions to kind of gauge the functionality and efficiency of our queue design. The first point was whether they can spot their time in line. All users said that they could clearly see their spot in line and the wait time, with Carrie saying, "Oh yeah, I see the wait time." Next, it was the lock screen display. Most users thought it was helpful to have a lock screen progress bar showing their queue status, but at the same time, they also thought that the lock screen interface looked a little bit more interactive than it should be with the dot. It made them feel like they could slide the dot across, move it to whichever position they wanted. So we redesigned the progress bar to look less interactive by putting an actual progress bar instead of a dot that looked like you can slide it wherever you wanted to. Lastly, we tested the animation engagement, the actual the whole page with the GIFs and everything. Some users said it was pretty, it was fun to look at the dog climbing up the stairs, while others said they wish it could be more interactive, like they wish that there was a game. We redesigned the queue screen to have both a numerical and visual aspect of line placement, allowing users to positively engage with the queue process. The use of animations enhanced the waiting process by ensuring the users that the wait time is progressing. At the top, there's a clear and accurate estimate of your place in line, as well as your wait time. The dog is progressing up the stairs to show that you're moving up in line. The animations at the back, like the birds flying and the car driving by, is to show you that the screen isn't frozen. And then once you've gotten to the top and it's your turn, you'll see the fireworks display. Like, woohoo, it's your turn. Like I had stated previously, we asked 4 main questions to gauge the functionality and efficiency of the queue design. The results are as follows. Question 1. Are users assuming they can or cannot exit the app to stay in queue? 70% of users said that they can. Question 2. Are users able to find the exit for the queue if they don't want to wait anymore? 67% said that they were able to find that exit. Question 3. Does the animation feature make it more enjoyable for users during the waiting process? All users said yes, it does. And finally, does the overall waiting process satisfy the users? 83% of users said yes, it did satisfy them. For our outcomes and lessons, our user testing proved to be highly beneficial. It provided us with crucial feedback to improve on our initial ideas and designs. We were able to redesign a pre-existing asset to make it more transparent and engaging for our users. Our next steps would probably be to expand on user testing to collect more data on the redesign after we would have made changes, and to meet with software and development teams to see if the redesign is actually feasible. Like, yes, we redesigned it, yes, people love it, but is it actually possible to recreate this? And lastly, what would we do differently? The first thing is to focus on one aspect from an earlier point in the brainstorming. I think at the beginning, we were trying to really focus on the big picture of fixing the entire ticket buying process, fixing the price transparency, fixing the queue management, fixing the seat selection. But if we focused on one thing from the jump, we would have been able to brainstorm more or like better ideas, and then also take into account more edge cases so that we'd be better able to prevent that. And then the last thing would be to think more as a user and less as a designer, because a lot of the things that we thought would be great initially, once we did get to usability testing, the users either didn't like it or was probably a little bit too complicated for them. So putting ourselves in the user's shoes instead of doing what we want as a designer should definitely be one of the things that we do differently. That's it. Thank you so much for listening. I hope the presentation was informative as well as enjoyable.